Okay, so I want to cover a couple of problems, hopefully dealing with the chain rule, all right? But before I actually do the problems, I kind of want to show you why this all works. Now, the notation that I have written here, dy dx. Now, especially if you're just starting out in calculus, this can kind of be a little bit confusing, but dy dx is not really a fraction, although a lot of times it acts like a fraction. Let me say it that way, all right? Now, in the same way, if I were to take 2/3 and multiply that by 3/5, and then multiply that by 5/8. If I wanted you to multiply that out, you would know that the 3's cancel out, the 5's cancel out, and I'd really be left with 2/8, which would end up reducing to 1/4. But I'm sort of relying on that cancel property. Now, with the chain rule, okay, a nice way to think about being able to do this is to say sometimes dy dx can be thought of as a fraction, and if I wanted to, it sort of acts the same way as a fraction does, and I can say that's really just dy d whatever, say dy d box, times d box dx. And the d boxes will cancel out, and I'll have that. Now, why do I say that? All right, watch. Let me scroll up, and let's look at this function right here. So I want to take the derivative of sine of x to the fifth. Now I'm going to show you how to do it fast in a minute, but here's like some of the mechanics behind it, right? What I'll do is I'll say this. I'll say y is equal to sine of box. And then I'll say box is equal to x to the fifth. Well, it's really the composition of two functions, and I just pulled it apart. Now, if I say this, if I want to know what dy dx is, because that's really the original problem I was after, the derivative of y with respect to x, what I can say is that's really the same thing as dy d box times d box dx. And if I look here, right, dy d box, well, that would just be cosine of box, right? Times. Now, if I look here, d box dx, that would just be 5x to the fourth. And then I'll take box and replace it with what it is right there, and I end up with cosine of x to the fifth times 5x to the fourth. And that would end up being my dy dx for that function. Now, typically the way we do this, or at least the way I think about it in my mind, is if y is equal to sine of x to the fifth, right? If I want to find dy dx, I ask myself, okay, well, what is the derivative of the sine of something? And I don't concern myself with what the something is. And the answer is that's the cosine of that something, right? But what I know, the something is x to the fifth, and then I have to multiply by the derivative of the something, which is 5x to the fourth.